Okay, let's get started with the question. First question. By the way, we are doing revision now, considering that, in your end of year exams is probably in another few weeks' time. Okay, so we're doing revision on all topics from P3 to 4, right? So this is a narrow road. At which position should the mirror be placed so that the driver in car 1 can see the driver in car 2? So this one obviously is under the light topic, right? How light actually travels. If you know about the concept well, you do know that light travels in a straight line. So this one is the underlying concept. Okay, the concept is that light travels in a straight line on this road. Yeah. So in this case, in order for it's straight, it cannot be curved, right? So it has to be like that. Okay. So therefore, the mirror should be placed at C. Right? Does any of you have a different answer? All of you have gotten C as your answer? Yes, you do? Yeah? Okay, so at which position should the mirror be placed? Is it definitely at C? Because then the light can be reflected upon. Okay, so that's the C, yeah? Question 2. A data logger was used to measure the amount of light passing through 3 different materials, H, I, and J. Which of the following is most likely to be material H, I, and J? Okay, I see a lot of people saying it's A. Anyone else has a different answer? Okay, now we look at this graph here. It seems like material H allowed very little light. I wouldn't say no light because if no light means it's at 0, but very little light. Okay, the one in the middle probably moderate light. And the last one, it has a lot of light, okay, or plenty of light. Okay, so in this case, of course, the one that gives you the most light to pass through, or rather the most amount of light that's able to pass through, will then be something that is quite clear, right? Quite transparent. So this is transparent. These are not. Okay. Then, of course, moderate light can be writing paper. And the one that allows very little light to pass through will be your wooden plank. So the answer is A. Okay, very good. I think most of you have gotten the answer for this one. Next one. Zhiling carried out an experiment in a dark room. She lined 4 25-centimeter square sheets in front of the torch as shown. The distance between the square sheets was equal. The square sheets were made of different materials. The diameters of the circular holes cut into sheets P and Q are 5 and 10 centimeters respectively. When she switched on the torch, the shadow that formed on sheet S is as shown below. Which one of the following shows the suitable materials used to make the 4 square sheets? Okay, so you notice that the shadow was formed on S, right? Shadow formed on S. So if the shadow is formed on S, it tells us that this one must be transparent to allow the light to pass through. And of course, S must be opaque, right? Someone wrote B here. Okay, never mind. I think I will disable annotation first because we want to go through first. Okay, someone said the answer is C, someone said the answer is B. Let's see if the answers are correct, okay? So if you notice, the shadow form is 1 of 10 centimeters. Right? So when she switch on the torch, the shadow form on sheet S is as shown below. Yeah. Okay. So this is the shadow form. And it's 10 centimeters. So if you notice, it will most likely be this one that is being cast on it. Okay, which means that material P is probably either transparent or translucent. Okay, because the shadow cast is that of 10 centimeters. So very likely this is the object that is opaque that will cast a shadow. Okay, so then we will decide which one is opaque. Okay, this one is opaque, opaque. This one is out. This is out. The final one must also be opaque. Okay, the final one must also be opaque because then it will be able to cast the shadow on it as a screen, right? Then R has to be transparent so that it allows light to pass through, so it's clear plastic. And then for P, be tracing paper. Yeah, the answer is B. Okay, answer is B for this one. Any questions? So far, the questions we've been doing are all light, under the topic of light. Any questions? No? Okay, if there aren't, we're going to move on to the next one. Okay, this one is heat topic. Okay, it's under heat. City has 4 setups as shown below. In which setup will the balloon inflate first? Oh, I'll need to remove the drawing. Okay. Someone said B. Now, this one is a very tricky question because if you think about it, okay, ask yourself, what is the change variable over here? What are we changing? Okay, so I think as you can see, everything is the same except that the material of the bottle is different, right? So since the material of the bottle is different, okay, you will need to see which one, what's the difference, or rather in terms of what property are they different. So when we talk about the materials, we are actually comparing the heat conductivity, right? This is the property that we're looking at. After all, this is a heat question, right? Heat topic question. So in this case, you will have to consider which one has the best conductivity amongst all the 4 materials. Of course, I think the best conductor will be the metal, right? And how does having a metal bottle help the balloon to inflate first? Oops, sorry, this one up here. Okay, let me just use this one. Okay, so we are looking at heat conductivity again, once again. So of course, this is the best conductor. And so what if it's the best conductor? When it's the best conductor of heat, okay, the air inside will gain heat, right? Air inside will gain heat from the hot water and the balloon will inflate. Okay, now being the best conductor of heat, it will be able to gain heat fastest because it's the best, right? So we're using superlatives here. So because it's the best, it will gain heat the fastest. And when it gains heat the fastest, what does it mean? It will also expand the fastest. And when it expands the fastest, what's going to happen? When it expands the fastest, the balloon will inflate the fastest. Okay, so that's why the answer is B for this. Yeah, better conductor of heat. Yes, correct. It's the best conductor. We don't use the word better because there are more than two. If you're comparing two, then you can use comparative adjective. If not, then it's, best and better. Okay, next one. Mr. Lim used 4 similar rods of different materials, W, X, Y, and Z, to find out which rod is the best conductor of heat as shown in the diagram below. He put a bean on 5 grams of wax at the end of each rod and heated the rods over a Bunsen burner until the wax melted and all the beans dropped. The time taken for each bean to drop was recorded in the table below. Based on the results obtained, arrange the materials from the best conductor of heat to the poorest conductor of heat. How is it linked? How is the results linked? Okay, I see someone typing in the chat now. Let me just quickly. Okay, Ivan said the answer is C, right? How do we explain this? Let's see if the answer is C, okay? Let's check whether Ivan's answers are correct. So the time taken for it to drop, of course, the fastest it dropped, what does it tell us? The fastest means it must be the best conductor of heat, right? Because then heat will be able to be conducted fast enough for it to drop. Okay, so in this case, actually, the answer is incorrect. It should either be A or B because it is taking the shortest time to drop, right? So that will be the best conductor of heat. And then the next one would be, of course, Y, because Y took the next shortest time to drop, then followed by W, then X. Okay, so this is an experiment. Again, this topic is on heat energy. Okay. Joe poured some hot drink X into a beaker and placed it in a basin of cold water as shown. He then plotted a graph to show the temperatures of drink X and water over a period of time. Which of the graphs below shows the correct temperature changes of drink X and water after some time? Catherine, you want to try?
Is it D?
Yes, very good. Okay, because eventually, drink X is hot, right? No, wait, let me see. Drink X, yes, drink X is super hot, and then the cold water is just cold. So it will eventually come to a same temperature, which is your room temperature. So answer is D. Very good, well done. Okay, because eventually things will start to gain heat to something, and something will lose heat to something, and eventually they will get to the same temperature. Right? Okay, I think we are done with your MCQ. We have the next one, which is your open-ended questions. Okay, I thought maybe you want to not take a break, but we'll watch a video of light first, light and heat, so that we can, sort of like consolidate the topic lah. Okay, basically we have done it for the past few lessons where we're covering different topics. Catherine, you have a question because your hands are raised. Any questions? No? Okay. Let me just look for the light energy. Okay, I hope you found it fun for those who are new. I think we seldom play Fishing Frenzy. I mean, once in a while we do. Okay, but I think most importantly, we have to look at the report. 66% of you got the questions. I mean, you guys as a class got 66% of the questions correct. Okay, now let me just have a look at the questions. I think 66% is not too good a score. Okay, by right, as of now, you've already covered all the topics, so you should be able to answer most of the questions, okay? Let me just quickly go through the questions. Only steel